right. So today I'm going to talk to you about privacy. Now, privacy is essential, and it is not only essential for criminals. So the fact that you require privacy doesn't make you a criminal. And I want to show you today that privacy is actually possible even on a system like Polkadot. You may have heard it in the news. There is a lot of polarization about privacy. That's why I started the talk the way I did. On the one hand, you have the crowd that demands absolute privacy, and even an attempt to be compliant is like blasphemy and can only lead to disaster. On the other hand, you have those who shit their pants because they might not be compliant and this might be bad for, So we really have those two poles, and we need to recognize Polkadot today is absolutely at the extreme, absolute surveillance edge today. And the reason why that is it gives you the impression that you have a certain privacy through pseudonymity because you're not on the blockchain with your name. But that will never hold long-term. Long-term pseudonymity will just reveal, through your behavior, will reveal who you are and what you do. Now, is there a compromise possible? Can we somehow deliver privacy for the masses, for 99% of the people, and still be legal by just allowing law enforcement to do their job? And that's basically what we want to present here. So let's not be over-compliant and just say, oh no, it's better if we don't do a privacy thing at all, because then the regulators could focus their attention on us. So we have a constructive proposal how Polkadot can embrace privacy, compliant privacy. I want to invite you to play along. So this will be a demo where I walk you through the thing that we actually built. This is live. It's live on the testnet of Polkadot on Paseo. So I will walk you through how our layer 2 solution enables you to privately transfer DOT, in the future DOT. Today it's PAS tokens. So what happens if you scan this? First we will take you to the Paseo faucet. Because we assume you have nothing installed, you need nothing. All you need is scan this QR code, you get to a web page. You don't need browser extension, nothing. You don't need tokens prior to this. So you go to the faucet, you solve a little CAPTCHA, and you will get 100 PAS tokens. So these are on the relay chain. And in the wallet, you will see the public balance. This will be your public balance. It's as if you take Nova Wallet, Subwallet, Talisman, whatever. It's exactly the same thing. You see your balance, you could send it around. But with our solution, you can now shield a part of that balance to the private layer 2. So you just say shield, and you say what amount, and that amount will be transferred to the layer 2 solution. And now you can do transactions privately, and there will be no trace on layer 1. Even the ones who operate the layer 2, they don't see what you do. And eventually you might want to go back to layer 1, maybe because you want to bring it to an exchange or whatever, to a different parachain maybe. Then you can unshield again, bring your balance back, and not necessarily to the same account. So what we can deliver to you is, even on layer 1, is K anonymity. That means if you transfer it back from the private layer, then you can be just in a set of all the others who do similar amounts with similar timing on layer 2. And the best thing of it all, and you see that from no other project, trust me, it's all in the same token. You pay fees with the same token that you want to transfer. So You need no other token than the pass for this demo to work. Now, how does it work under the hood? You have an account. We created that for you. That's simply a Polkadot account like you know it. You do a transfer to our vault account. This vault is a pool that holds all the pass tokens which live on L2. Now, we run trusted execution environment validators on L2, and they have a light client into the relay chain, which means we can trustlessly observe all the transfers that go into the vault account. That means we can issue the same amount on your account on L2. So that was the first step. You send a transaction to the vault account and you get a new balance up here. Now you can do transfers. This up here is also a substrate-based chain. So you can do everything you can do with substrate, you could do it up here as well. On INCOGNITEE for now, there's just the balances palette, but there could be a DEX, there could be whatever you like, there could be NFTs if you like. But for now, for this demo, it will just be transfer of tokens. So you send your friend a couple of USDT maybe, because the nice thing here is we can not only do that with DOT, we can do it with USDT as well. And think about it. If you want to, I don't know, you're at the restaurant, someone pays for everybody and you just want to give them a couple of USDT for your share. Would you do that with your current Polkadot accounts? Would you really expose all your wealth you have in Polkadot and all your behavior to your friends? Would you like to do that? I don't know, I wouldn't. So how do you do it today? Today you try, at least I try to have a certain account hygiene, but using centralized exchanges. It's like, well, you deposit to a centralized exchange, you withdraw to a different account, and then at least you don't leave traces on layer 1. But that's really bad for multiple reasons. Exchanges can be hacked, data can leak, and, well, it's centralized. So that's not what we're here for, right? So this is the story how we can get beyond that stage with account hygiene. So how does the unshielding work now? So on the centralized exchange, you just say withdraw and you select a new account. The same thing you can do here. You can do unshield and name a new account that you want the unshield happen to. So the validator here just has proxy control on the vault account and says, okay, transfer that amount to another account. So if you unshield 10 pass, they will be burned on layer 2, and they will be sent from the vault account to account B. Now, this sidechain has slightly different consensus properties than substrate chains or that Polkadot has. So we do use the INTEGRITEE parachain for finality of the layer 2. The idea is that up here we can have 1 second block times. We could even have 300 milliseconds, but our current demo has 1 second. And if you play through the demo, you will see how quickly you can really pay at the point of sale with this solution. It's so quick. But we need attestation of the enclaves and finality over here. Maybe I'll have enough time today to explain more how that side works, but I want to focus on what you as a user can get out of it. So let me show you this demo. I hope the video will start. Yes, it does. So if you do it, you go to the faucet, you paste your account. You will need to solve a little CAPTCHA. So if you want to do it at the same time, please feel free. It will only take a minute. So this is the Polkadot faucet. It's not us doing that. So you got 100 pass on your public balance and nothing on the private balance because it's a new wallet. Now you can say, I want to shield, let's say, what have we decided here? I want to shield 50, yeah, okay. We will charge you a little fee when you shield. And then we need to wait for finality on L1. But as soon as it's finalized, you actually have your balance and you can send it to someone. You can scan their QR code like you know it from other wallets. So you send 3 PAs and boom, it's already done. I will show you on. So this would be the other side. That was the receive side showing the QR code, and it's already there. Maybe you pair in twos if you want to try it. It's a bit more impressive. Unshielding works in a similar manner. You just say which account you want to unshield to and how much. And then it will send an extrinsic to the L1 and grant you your balance again. So as simple as that. Now, what from this whole process, what is actually visible to the public? The shielding obviously is visible because you are on L1 sending funds to the vault. So if you go to the Paseo Explorer, you will see a transfer from your account to the vault account, and we actually shielded 50 PAs. Then someone else was shielding. That is not of interest for us. And we also unshielded in this demo. So you will see a transfer from the vault to the account that you selected. In this demo, we chose the same account because it wasn't necessary to it was the choice of the demo, but it could be any account here. Now, you immediately see where the caveats are of k-anonymity. So if you are the only one, the only user on this platform, there's a shielding and there's an unshielding here. Well, most probably that's the same person. Maybe it's the same amount. So you shield 44 PAs and you unshield 44 PAs to a different account. Well, maybe that's the same person. But imagine the same happening if everybody strictly unshields 10 PAs. And if we randomize the timing, then you get k-anonymity, and the k is you are 1 out of k, which could be the originator of this unshielding. That means if 100 people do the same during the same few whatever instant of time, then you are 1 out of 100. Maybe you know other privacy coins. Monero, for example, gives you a k-anonymity of 1 out of 16. And here it is usage-based. So the more users we have, the more transactions happen, the better your k-anonymity. Okay, now how can this be compliant? I'm sure you have heard of a few cases in the media where, and you wonder, why is this guy here standing on stage if he knows that he's going to be in jail for 5 years pretty soon? So I'm absolutely convinced that law enforcement is necessary. So we are not in the game to help criminals kind of obscure their traces. What we say is privacy should be the default for everyone. So let's quickly explore other privacy technologies. I'm sure you know Monero, you know Tornado Cash, and this is us. The reason why, or Tornado Cash, they tried to offer certain tools for compliance as well, but they always involve that the individual collaborates. So if you have a set of inputs to a mixer like Tornado Cash, then you, as the person that goes through that mixer, you can generate a zero-knowledge proof that says, my money only comes from this set of inputs. Now, if you have a whitelist or a blacklist, you can say, my input is from the whitelist, or there is no input from a blacklist which went into my output. You can do these kinds of proofs, but the problem is you need the collaboration of the subject. That means you already need to know who it is, you need to be able to talk to them, and then they need to comply. Now, that's not the way law enforcement can do their job, I think. Maybe the tax authorities can do it that way, but not law enforcement. Monero has a slightly different approach, but it's similar in the guarantees. So Monero gives you the possibility to create view keys that you can disclose to someone where your money comes from. Now, this is about the limit of what zero-knowledge proofs can do. Because with zero-knowledge proofs, you need to define all the rules a priori, and if the proof is there, there's nothing you can do about it anymore. You cannot do rate limiting of any kind. You cannot do disclosure without getting more key material in. But the fact that we use trusted execution environments allows us to program the rules of privacy. That means we can define the rules when to do selective disclosure of data. Or we could even program the rules for freezing funds. Maybe we need to comply with sanctions, with blacklists that need to be frozen. This is all possible because it's programmable. I'm not here to tell you how exactly that process will look like, but think of it a bit like maybe a collective on Polkadot could have the authority to just examine proofs, evidence of criminal activity, together with a law enforcement request to get selective information about one account. Then the TE we could program the rules such that if that body, that multisig, that collective, that whatever, decides that data needs to be disclosed, the TE will respect that. Now you could say, well, if that is a body, an elected body, the problem is law enforcement, or let's say state agencies, will coerce those people in those seats to more or less disclose everything. You know, like backdoor, show us everything. Now, thanks to the fact that we have a TE, we can prevent that as well. Because we have a notion of time. Zero-knowledge proofs, they know nothing about time. But we have a second layer which knows the time from the blocks that are on L1. That means we can do rate limiting. We can say law authorities can only query the balance of, I don't know, 1 account per day, something like, you know. It's really a hypothetical example. But we should explore this space. We should proactively show the regulators what is actually possible to do to become compliant, and then find a compromise where we can get privacy by default, but still like reasonable access for law enforcement. Yeah, okay, this I already told you. Now, I hinted at it. INCOGNITEE is the product that I was presenting to you now. This is our first user-facing product. So far, we have focused on just confidential computing, a platform for remote attestation, and so on. But we have plenty of other ideas of what you can do with the same technology. we already have one proof of concept, well, actually, testnet demo of blockchain gaming with IUNA. The good thing for gaming is we have very low latency, we have sub-second block times, but also what you can get is non-deterministic execution. You can get verifiable randomness, and that's all very, very good features for gaming. Exchanges. This might even be integrated in INCOGNITEE. So imagine we are a second layer on the asset hub. That means we have access, we can shield all those tokens which are on the asset hub. USDT, well, DOT, all the parachain tokens, you name it. If we can shield them, we can also swap them. That means you get a decentralized exchange without front running. Because all the bits, all the trades happen privately, you cannot front run. There is no minor extractable value there. Because even the validators, they don't see what you want to do. That's the beauty of trusted execution environments. Yet another angle is identity protocols. So imagine you have your credentials on Kilt. The way it works now is you have the liberty to disclose data to different parties, but the problem is if those parties collude, that you can be linkable. So whenever you use your DIDs, you could actually be linked behind the scenes. This is a thing that we can help with as well. And we have actually someone using our SDK for that purpose, and that's the Litentry team. Another Polkadot parachain. So I only have like 2 minutes left. I think there are really other talks where I explain in depth what Ts are, how remote attestation works, and why we were able to decentralize that. So let me just give you a very elevator pitch on what a TE is. We use Intel SGX. That is a technology where Intel as a manufacturer guarantees for the design, and the design makes sure that whatever you execute inside the TE works on encrypted memory and cannot be changed in terms of the code that you execute, not without noticing. And this is especially interesting because also the operating system, whoever is root on that server, doesn't have access to that data. So they cannot see what you do, and they cannot arbitrarily change how your data is processed. Even if you trust your admin, even if you trust your cloud provider to do a good job and not to spy on you, the problem is even they can be hacked, even Google can be hacked. And if they reveal your data, your use case might just be dead. Now, the last minute I will spend on why is the INTEGRITEE network necessary here. Intel only went that far with remote attestation. They still kept quite a bit of control if you want to prove that you are an enclave. They have opened up quite a bit. Now data centers can do that as well. But you're still relying on a third party to verify that you're actually interacting with a trusted enclave. Now in the blockchain space, we don't like that. So what we did is we took that validation logic, which usually Intel themselves execute or data center providers execute, and we put that piece of code on our chain. That means the enclave can now do remote attestation. My enclave that I run registers on the parachain, and you can, on a public blockchain, you can verify that I'm running the right code on a genuine machine. And the good thing is this is uncensorable, unlike Intel's designed solution, which can be censored, because if they don't like the code that you want to execute, they can just refuse to give you remote attestation. This cannot happen with our network, because it lives on a blockchain, it is unpermissioned, so that means everybody can use it and Intel can do nothing about it. Thank you, that was it. Happy to take questions.
Alain, thank you very much for your presentation. An amazing topic. People, some question? Yeah, we have a question there. Wait for the microphone.
I think I need the mic to hear.
Yeah, perfect.
Can you hear me? Okay.
Yes.
So I guess when mainnet launch, and also are you working on wallet integrations?
Important questions. So first, when mainnet launch, this also depends on you guys, because we recently had a treasury proposal to accelerate this. Unfortunately, it was refused for various reasons. But anyway, if you have DOT to vote, we will come up with a new, we will work it over, take in the feedback. You can help accelerate. Our plan is to be live on the Polkadot relay chain by the end of the year, or let's say Q1 of next year. But this comes down to the funding, and we need support there. And then the wallet integration, what you saw here as a demo is really just a web dApp. What we can easily do is build a dApp that you can, for example, use inside Nova Wallet dApp Explorer or a dApp browser or Subwallet dApp browser. We can do that, but there is a challenge there, because only you may query your balance. That is not the concept which the other wallets support, because blockchain, they are transparent. Everybody can see the balance of everybody else. That means we need to change the flows of those wallets, but we are in talk with other wallet providers. But I mean, it just so happens that usually first you need to be live and show that there is traction, and then the integrations will come. Yeah.
Maybe one last question. Are you having some tools or measurements to show the user that is trying to unshield how private that would be?
Yes. Actually, that is a very good feature to have, but it's a tricky one. Let me explain you why. If you have currently a k-anonymity of 16, like Monero has, the problem is you could be poisoned with your k-anonymity because someone could flood the activity and provide the 15 others, so they know that they are the 15, so you have to be the 16th. Then your k-anonymity shrinks to 1. Now, that's why we need to be really careful about promising a level of anonymity, but basically we will give you an indication of how much, like which accounts and which frequency is currently happening, and then you can basically choose, you can trade off latency with privacy. The longer you are willing to wait, the more privacy you can probably get. But if you need it immediately, you can have it.
Can you also schedule unshields?
Well, that would be a feature that we would do as an extension.
Thank you.
All right. Alain, I have another question.
Please.
Because we still have 1 minute more. And that question caught my mind in the moment that I see the title of this presentation. I am reading it for you. Why Integrity considering privacy something very important?
I think it is crucial for humans to feel a sense of privacy. We naturally do it. You're not going to the toilet if you're in the middle of a square in a glass house. You're not doing that, right? So there is a very fundamental feeling which has been lost in the digital space. A lot of people just don't care, but that's because they don't see what they're actually opting into. But there's a different reason, and that goes a bit towards OpenGov. In OpenGov, if you vote, you have to fear, even if you're pseudonymous now, you might be doxed in the future and people see how you have been voting. Now that does something to you. Even if you have a very strong character, the fact that your vote is public will tend you to be submissive, to go with the mainstream, even if not always, but there will be a tendency that you behave how others expect you to behave just because your actions are transparent. And this is not what democracy is about. This is not what freedom is about. This is not what innovation is about. You need some privacy to explore in freedom. That's why we care about privacy.
Yeah, thank you very much, Alain. Applauses and good night for him. Thank you very much.